Okay, now let's look at another example of a small system. Here we have 3x plus 2y equals 3, 4x plus 5y equals 11. And by now you should be pretty familiar with putting this into an augmented matrix. So here's your augmented matrix form. So I'll just copy it down here to start working the problem. Okay, so I need a 1 right here. So I'm going to just simply multiply this by 1/3. There's no 1 below it that I can swap with this time. So I'm just going to take this 3 and multiply it by 1/3. And I can do that as long as I multiply each term in this row by 1/3, because that's a legal row operation. So if I do 1/3 times row 1 and put the result in row 1, I get 3 times 1/3, which is 1, 2 times 1/3 is 2/3, and 3 times 1/3 is 1. And make sure you do this in fraction form and not try to use decimals. So leave that as a fraction. So we're going to copy it down here. Again, I'm copying these down to show you to do the next row operation. So right here we have a 1. And we know we have to add a -4 to +4 to cancel it. So I'm going to multiply this row by -4. And then I'm going to add the result to row 2 and then put the result in row 2. Now let me show you what would happen if I multiplied everything in row 1 by -4. I get -4, and then 2/3 times -4 would be -8/3, and then of course 1 times -4 would be -4. So I need to add those values to row 2. So -4 plus 4 gives me 0. -8/3 plus 5/3. You'd have to get a common denominator here, and 5 can be written as 15/3. So -8/3 plus 15/3 is 7/3. And then -4 plus 11 is 7. Okay, so then I'll copy this matrix down here to do the next step. Now the next step, I go down to the second row and I go to this second entry here, this 7/3, and I want to make this 7/3 a 1. So the easiest way to make this a 1 is to multiply this by 3/7. So that means I have to multiply everything in row 2 by 3/7. Well, that's pretty easy. 0 times 3/7 is 0. 7/3 times 3/7 is 1. And if you multiply 7 times 3/7, the 7's cancel and you just get 3. And so now I have the 1 here that I needed. And finally, I'll copy this down here. And there's the 1 that I needed. And I need to multiply this row by something so that when I add it to 2/3, it'll cancel it. So that would be -2/3. So if I multiply this row by -2/3, then what I would get, and again you can kind of write this down here if you want to, -2/3 times 0 is 0. -2/3 times 1 is -2/3. And then 3 times -2/3 is just -2. And then if you add these to row 1, 0 plus 1 gives me a 1 right here. -2/3 plus 2/3 gives me a 0 here. And then -2 plus 1 gives me a -1 here. So now I have my answer. I know from row 1 that x is -1, and I know from row 2 that y is 3. So the solution here is x equal -1 and y equal 3. Okay, so in those two examples there was some repetition. So here, let me just go ahead and show you an example without me duplicating the matrices in each step. So here we're going to solve the system 2x minus 3y equals 5, x plus 2y equals -3. So the augmented matrix, row 1 would be 2, -3, 5. Row 2 would be 1, 2, -3. Well, since I need a 1 right here and I have a 1 below it, all I have to do is just swap these rows. So I'm going to take row 1 and swap it with row 2, and that'll put the 1, the 2, the -3 in the first row, and the 2, the -3, and the 5 in the second row. Okay, so now I need to multiply this by something so that when I add it to row 2, it cancels the 2, and that would be -2. So multiply row 1 by -2, and if we multiply row 1 by -2, we're going to get, let's see, we're going to get negative 2 times 1 is negative 2, negative 2 times 2 is negative 4, and negative 2 times negative 3 is positive 6. So I'm going to add these values to row 2. Negative 2 plus 2 gives me the 0 that I'm going to put here. Negative 4 plus negative 3 is going to give me the negative 7 that I'm going to put here. And then 6 plus 5 is going to give me the 11 that I'm going to put here. Okay, so now I need to make this a 1. So what I'm going to do is I'm just going to multiply this row by the reciprocal of negative 7, so that when I multiply negative 7 by its reciprocal, it gives me 1. Now again, I multiply everything in this row by negative 1/7. So 0 times negative 1/7 is 0, negative 7 times negative 1/7 is 1, and 11 times negative 1/7 is negative 11/7. Okay, so now the last step is I need to multiply this 1 by some number and add it to the 2 to cancel the 2. So since negative 2 cancels positive 2, I'm going to multiply row 2 by negative 2, and then I'm going to add the result to row 1. Now if I multiply row 2 by negative 2, that would actually give me negative 2 times 0 is 0, negative 2 times 1 is negative 2, and then negative 2 times negative 11/7, that would be negative 2 times negative 11, which would be positive 22 over 7. Now then I add these to row 1. 0 plus 1 gives me the 1 right here. Negative 2 plus 2 gives me 0 here. And then I have to add 22/7 to negative 3. And you can write negative 3 as negative 21 over 7. So 22/7 plus negative 21 over 7 gives me positive 1/7. So now I have my augmented matrix in reduced row echelon form. And so now I can just read the answer. X is 1/7 and Y is negative 11/7. So this time the answers didn't come out to be nice round integer values. They turned out to be fractional values. Okay, I'll finish this up with a dependent system and an inconsistent system just to show you how to recognize those. So let's start with this example. I'm going to use x1 and x2 instead of x and y, but don't let that bother you. Just treat the x1 like you would x and the x2 like you would y. So the coefficients here are 2, negative 1, and the constant's 4. Your second equation, the coefficients are negative 6, 3, and the constant's negative 12. Now, I want to make this be a 1, so I'm going to multiply row 1 by half. So 2 times a half is 1. Negative 1 times a half is negative 1/2, and 4 times a half would give me 2. Now I want to multiply this row by a number that will cancel the negative 6. So if I multiply this by 6 and add it to negative 6, it will cancel it, right? So I'm going to multiply row 1 by 6 and add it to row 2 to get the new row 2. Now let me show you, if I multiply that row by 6, 1 times 6 is 6, negative 1/2 times 6 is negative 3, and then 2 times 6 is actually 12. Now what's interesting here is if I add 6 to negative 6, I get 0. If I add negative 3 to 3, I get 0. And if I add 12 to negative 12, I get 0. So now I've got this in reduced row echelon form, but notice this time I don't get a unique solution. Here, the first row tells me that x1 minus 1/2 x2 equals 2. Okay, so x1 minus 1/2 x2 equals 2. And the second row tells me just that 0 plus 0 equals 0, so that 0 equals 0. Well, this is what happens when you have a dependent system. So we have a dependent system, so in other words, these two equations represented the same line. So since they're basically the same equation, so I can solve the first equation for x1 in terms of x2, and I get x1 equals 1/2 x2 plus 2. And so now I can let x2 just be x2, and then I know how x1 is related to x2. It's related to x2 in this fashion. X1 is 1/2 x2 plus 2. So, and x2 would represent all real numbers. And you could use another variable like t or k here if you wanted to. You would just say x2 is t, and then you know x1 is related to it in this fashion, 1/2 t plus 2, or you could use k as I did here. So anyway, that represents an infinite number of solutions since this value here. So if you use t could be any real number. So if t was 0, then this would be 2. If t is 1, this would be 1/2 plus 2. If t was 2, this would be 1/2 times 2 plus 2, and so forth. So anyway, since t can be any real number, that gives you an infinite number of solutions there. Now, to wrap this up, let's say that I did a similar problem like this. So 2, 6, -3 would be the first row, and 1, 3, 2 would be the second row. Well, here I can just swap the two rows and get 1 right here. Well, then I can multiply this row by -2 and add it to row 2 to cancel this 2. And so if I do that, if I multiply this row by -2, I'm going to get -2, -6, -4. And then if I add these values to row 2, -2 plus 2 would give me 0. -6 plus 6 would give me 0. But -4 plus -3 gives me a number other than 0, -7. So this time the first equation would read x1 plus 3x2 equals 2. But the second equation gives me an impossible equation, 0 equals -7. So in that case, I know I have an inconsistent system, so therefore I have no solution. So that's how you identify dependent systems and inconsistent systems when you're solving problems that are small like this. Now, in the next section, I'll show you how to solve larger systems using augmented matrices.